A family secret exposed.
If my father wasn't my biological father, who was? Something very, very important was kept from me.
A hidden legacy revealed.
Somewhere in slavery, that 20% might have been integrated with our DNA, and that might not have been voluntary.
A life-threatening illness prevented.
They quite possibly saved my life.
And a decades-old murder finally solved.
Without my DNA, it would have been dead in the water.
Just a few of the millions of stories launched by one of the most popular and promising new technologies. Consumer DNA testing. With a swab or a bit of spit, some 30 million of us have turned over our most personal information, hoping to discover what's hidden inside us. But what do the tests really deliver?
Spain, Portugal, Norway?
How good is the science? And how are the tests changing our lives?
I just couldn't believe it. I was on the phone with my oldest sister.
In search of clues, the secrets in our DNA. Right now on Nova. It's a promise many of us just can't resist. Send in your DNA and unlock secrets about family, ancestry, and even health.
It's rare that something comes along that is truly new. And this is something that's truly new.
But just how reliable are consumer DNA tests and their scientific-looking ancestry percentages? Should we worry about our privacy? What are the unforeseen consequences when we reveal the secrets in our DNA? In the suburbs of Olympia, Washington, one woman finds out just how unpredictable those consequences can be. Chelsea Rustad, who works as an IT specialist, is an avid family historian. In 2015, she takes a test with the biggest of the direct-to-consumer companies, AncestryDNA.
People end up doing it oftentimes because, oh, I just want to learn about my ancestral background. But then something else pops up that they really were not expecting at all, and that's exactly what this was for me.
The test results suggest that Chelsea is mostly of Norwegian and German ancestry. Then, because she's also curious to find new relatives, she downloads her raw file from Ancestry and uploads it to a free website called GEDmatch. It's a place where anyone can search for matches no matter what company they tested with. GEDmatch shows Chelsea everyone else on the site who shares DNA with her.
It's kind of humbling and interesting to see those interconnections, to realize the sheer number of people that we share some percentage of DNA with and don't even realize it.
On GEDmatch, Chelsea sees an aunt, whom she knows, but no new close relatives. She logs off and doesn't check the site again. 3 years go by. And then, on the evening of May 17th, 2018, Chelsea gets some unexpected visitors.
I look through the people and see that there are 2 cops waiting outside there. And when I opened the door, they introduced themselves as investigators who are looking into a homicide that was a cold case from 31 years ago.
They've come to her door as a result of that DNA file she posted on GEDmatch. To her amazement, They tell her that her DNA has led them to a suspect.
It was just really a lot to take in and really shocking. Every step of what they explained to me is a horror story.
Chelsea's hopeful search for relatives has taken a dark turn into the hunt for a killer, someone she's related to. Though her story is unusual, it shows that consumer DNA companies can fulfill one of their biggest promises extremely well, connecting us to our relatives. Direct-to-consumer, or DTC DNA testing, is a billion-dollar business made possible by the simple rules of heredity.
We inherit our DNA from both of our parents. 50% from mom, 50% from dad. And they inherited it from their parents. And their parents, of course, inherited it from their parents.
Our parents each contribute about 50% to our DNA. And the same is true for them and their parents. So the amount of DNA we inherit from any ancestor drops by half with each preceding generation. We also share DNA with anyone who shares a common ancestor with us: siblings, half-siblings, first cousins, second cousins, and so on. The way that the DTCs determine those relationships is by comparing people's DNA. The amount that is shared is measured in a unit called centimorgans.
The more centimorgans two people share, the closer they are related. And the fewer centimorgans they share, the more distantly related they are.
But with the DTCs, a relationship to someone can't always be determined just by counting centimorgans, because the numbers fall within ranges. You might share the same number with a cousin and a great uncle, for example.
Just because you have an amount of shared DNA doesn't mean you actually know for sure what that person's relationship is. It's just a probability, a spectrum of possible relationships.
June Smith lives in New Jersey, not far from Philadelphia. In 2018, she takes a consumer DNA test, hoping to solve a long-standing mystery. She's spent years searching for her roots. When June was 16, growing up in Philadelphia, the woman she knew as her mother revealed a secret.
She said, "Your mother was a white woman." When I said a white woman, which was totally shocking to me.
Her biological mother's name was Ann D'Amico. June has never learned the identity of her father. When June takes her test with AncestryDNA, she checks the box asking to be linked to any customers with whom she shares DNA. Though she knows Ann has died, there's someone else she desperately wants to find. While digging into Ann's life story, June learned that she'd given birth to another biracial daughter who had a different father, a girl named Joan Moser, June's older half-sister.
I set out to search for her. And I would go on websites. I would do all kind of people searches, looking for Joan Moser, but we could never come up with her.
One day, June receives a message on her Ancestry page telling her she has a new match with a close relative, a woman named Sigrid Gilchrist. She'd also grown up in Philadelphia, the only child of a Black couple active in the civil rights movement. But at 16, Sigrid learned a long-hidden truth from her mother.
She told me I was adopted, that my mother was Italian and my father was Black. It was crushing. I had no idea.
In the years that followed, Sigrid never connected with any of her biological relatives. Until, by pure chance, right around the time that June tests with Ancestry, Sigrid does too. Ancestry reports that the two women, who share 1,641 centimorgans, may be first cousins. But June can't help wondering, might Sigrid be someone even closer? The two women agree to talk on the phone.
She said, I have 3 questions to ask you. I said, okay.
I said, were you adopted? She said, I was. I said, are you biracial? She said, I am. I said, would your birth mother name happen to be Ann D'Amico?
I said, yes, that was her name, my biological mother. She said, are you Joan Moser? And then I said, that was the name on my birth certificate.
I said, oh my God, you're my sister, you're not my cousin. We cried and I just couldn't believe it. I was on the phone with my oldest sister. Yes.
It was just like we've known each other forever. One-on-one spirit feeling that you can't describe.
Finding my sister gave me a sense of belonging. It gave me a sense of saying, hey, you know, we got the same blood.
But I do see
Looks
you.
like me.
Yes.
Mm-hmm. With the chin.
Yeah, I know.
It's good having an older sister.
I don't like being older, but it's okay. I love having a younger sister.
She understands.
Yeah.
People like Sigrid and June can be connected by the DTCs thanks to an amazing recent discovery about DNA. We've known for a long time that the DNA molecule, which we carry in almost every cell in our body, contains the code that directs our lives. The code is carried in chemical building blocks called bases. Known as A, C, G, and T, they form pairs to create the familiar ladder-like structure of DNA. It takes a whopping 3 billion of those base pairs to make up our complete genome. But since 2003, when scientists first read through all of those base pairs, they've discovered a surprising fact about more than 99% of them.
So if you look at any two people, the vast majority of their DNA is exactly the same. Because all of the things that keep you alive, I mean, all of that has to be the same. It can't change, otherwise it doesn't work.
But there are places in our DNA that do vary. Some of them are called single nucleotide polymorphisms, or SNPs. They're spots where most of us have one kind of base pair, but some of us have another. So instead of trying to identify all 3 billion of a customer's base pairs, the DTCs do something that's cheaper and faster. They only check out a customer's SNPs, usually about 700,000 of them. And comparing people's SNPs is an efficient way to see if they're related. Because when their SNPs match up, all the DNA in between the SNPs is usually identical too. And matching DNA segments are the telltale signs of a family relationship.
By looking at the amount of shared DNA, direct-to-consumer tests can give a quite accurate picture of relationships between individuals.
Family Tree DNA in Houston is one of the 4 biggest DTCs. Like many of them, the linchpin of its operation is its technology for reading SNPs. And this is it, a small piece of glass called a SNP chip. It contains hundreds of thousands of tiny beads. Each one holds a short piece of DNA called a probe.
And we put an individual's DNA on the chip, and the part of an individual's DNA that matches the little probe, they will bind together.
Once bound, the identity of the SNP is revealed by a fluorescent dye.
For example, if you have an A, you'll see green. If you have a G, you'll see red.
The SNP data enables the lab to see how much DNA is shared by customers who've opted for family matching. The company website shows them their list of matches.
It will show everyone that you're related to and the estimated relationship.
But sometimes, that match list can reveal a painful truth.
This anonymity and taking these secrets to the grave with the advent of DNA testing, it really doesn't exist anymore.
That's what Dani Shapiro was shocked to discover. A novelist and memoirist, she's written about growing up in an Orthodox Jewish family in New Jersey and about her parents, Irene and Paul.
I was very, very bonded with my dad, much more so than with my mom. He worked on the floor of the New York Stock Exchange, and I would meet him for lunch sometimes, and he would come out and he would just like fling his arms open, just like, hiya, darling, give me this huge hug. It's gonna make me cry. I loved my father.
From childhood on, this Jewish daughter draws comments.
You don't look Jewish. You can't possibly be Jewish. There's no way you're Jewish. Did your mother have an affair with a Swedish milkman? Shapiro, your married name? I could go on.
One day in 2016, her husband, Michael Marin, decides to take a DNA test from Ancestry. Without thinking about it much, Dani decides to take one too. She knows that both of her parents are of Ashkenazi, or Eastern European Jewish descent. Several weeks later, they get their results.
We open them, and he's like, huh, according to this, you're about 50-50 Eastern European Ashkenazi, and the rest is all Western European, French, Irish, English, Swedish, German. My only response was, oh, well, they must have made a mistake. It was only a few days later, my husband came in and he said, you have a first cousin on your Ancestry.com page. A first cousin who we don't know this first cousin.
In search of clues, Dani turns to someone she's sure is a blood relative.
I have a much older half-sister from a first marriage of my dad's. I recalled that a number of years ago she had done, I think, 23andMe. And I sent her an email and I said, do you have your results from the DNA test you did? And she did, and she sent them to me.
Dani gives the half-sister's file to her husband. Using GEDmatch, he checks to see how much DNA she and Dani share and discovers the truth.
He said, you're not sisters. And I said, not half-sisters, because that's what we were. And he said, no, kind of sisters, you're not related. And so that was the moment for me when all of the pieces began to just click into place where I thought, well, if he's not one of our fathers, he's not my father. Something very, very important was kept from me, and it felt to me like my identity was in pieces.
Her parents are both deceased, but she remembers her mother once saying she had a hard time getting pregnant and mentioning a fertility clinic in Philadelphia. Dani and her husband tracked down the first cousin who popped up on Ancestry. His uncle turns out to be Dani's biological father. A retired doctor, he'd gone to medical school in Philadelphia and had been a sperm donor at the clinic. She searches the internet and sees a video of him giving a talk.
I knew what I was seeing. And I remember getting up and walking into the bathroom and looking at my face in the mirror for the first time after seeing him and understanding my face for the first time in my life.
Dani feels compelled to write a new book about family, identity, and her own experience. Its title, Inheritance.
My book is dedicated to my father. And sometimes someone will say to me, which father? And I'm like, are you kidding? My mother wanted to bear a child, and I think it must really not have been easy for my father to have gotten to this place where he was willing to genetically replace himself. That's what that is. It's saying one of us is going to be the biological parent of this child and one of us is not. And no one's ever going to know except for us.
Danny is far from alone. According to one estimate, some 1 million people have discovered from consumer DNA tests that the man who raised them is not their biological father, or that they have a half-sibling they never knew about. And there are even darker secrets that sometimes come to light. In Washington State, in 2018, the secret that Chelsea Rustad's DNA helps to reveal could be the key to cracking a 31-year-old cold case.
It's really upsetting, very distressing to think about. Only a monster could do such things to people.
On November 18th, 1987, two young Canadians, Jay Cook, 20 years old, and his girlfriend, Tanya Van Kuylenborg, 18, leave their hometown, a suburb of Victoria, British Columbia, heading to Seattle to run an errand for Jay's dad. 6 days later, Tanya's partially clothed body is found by the side of this road in Skagit County, Washington. She's been shot in the head, and there's evidence of rape. 2 days after that, some 65 miles away in Snohomish County, beneath this bridge, hunters find Jay's body. He's been strangled with twine and dog collars, his head beaten with rocks.
We had two young, totally innocent kids that got kidnapped and brutally murdered.
During the investigation, police recover potentially precious evidence from Tanya's body, the assailant's DNA. They will run it through a lab procedure that is still the gold standard for proving identity with DNA. It zeroes in on just 20 or so places in the genome where a short string of letters, for example, GATA, just keeps on repeating. They're called short tandem repeats, or STRs, and scientists can count the number of times they repeat.
And those counts vary person to person, just like the ridge lines on a fingerprint. It's a very powerful technique because with enough locations, you can do an identity match with very high probability because of these slight differences one person to the next.
But like a crime scene fingerprint, a crime scene STR profile is only useful if it matches one that's already in the possession of law enforcement. For decades, the profile in this case doesn't match anyone known to the police. The case goes cold. Until the day when Chelsea Rustad uploads a DNA file to GEDmatch, where it becomes a clue that will eventually lead the police to a major break in the case. Chelsea's experience will make headlines. But most DNA test takers just want to know, what are my roots? A seemingly simple question that often leads to its own set of mysteries.
Don't open anything until we ask you to.
These 14 people are about to experience DNA ancestry testing for themselves.
Because there are so many kids I'm growing up with who are all in the same situation. We don't know our heritage. We could probably safely assume that our ancestors' ancestors had something to do with like slavery and things like that, but we don't really know where we came from.
Cherry Richardson is taking part in a research study at Westchester University in Pennsylvania.
So we have a research protocol by which we collect data for this particular project.
The study is run by two communications professors, Bessie Lawton and Anita Foman. The question they're asking is, how does DNA testing affect our understanding of who we are? And also, our ability to understand what makes us different.
And after we receive the results, we bring you together.
The whole idea is to listen to each other and talk with one another.
Anita was inspired to start the project because of her experiences as a diversity trainer.
I thought looking at our DNA was a really interesting way to approach this whole conversation about race and diversity in a way that was not going to make people defensive, and that has happened.
We don't identify ourselves as Africa. We just say we're black. You know, we literally separated from that which we came from.
In a previous test with Ancestry, Taekwon Golden was told his roots were 80% West African and 20% British.
They got everybody.
In today's test with Family Tree DNA, he hopes to learn more.
My suspicions might lead me to say somewhere in slavery, 20% might have came in and have been integrated with our DNA. And that might not have been voluntary.
I think as an African American, it's a tough thing to grapple with when you think about the origin of your Caucasian or white ancestry that often happened due to rape and mistreatment. But it is part of your history, so you have to confront it on some level and understand it. It's part of how you got here.
I don't want to hide from the truth, no matter how bad it could be.
Now it's time to collect DNA.
You can turn it around a little bit to capture more.
And ship the samples off to Houston.
Thank you.
So how do DTCs like Family Tree DNA come up with a breakdown of your ancestry? It's a process that also centers around SNPs, those places in our DNA that most frequently vary between people. The company compares your SNPs with those of people in what are called reference groups. People alive today whose DNA has been tested and who share patterns of SNPs that scientists have found to be typical for the region in which they live. Those patterns are compiled into a database. But how well does it represent test takers?
They're telling you this is your background based on our database. Well, if something's not in their database, they can't tell you that it's in your background.
The DTCs have less data about people of African and Asian descent than they do about people of European descent.
Most of the genetic testing that has been done on North Atlantic Europeans. So our reference databases are biased.
Why don't we all just take a minute and open your results and take a look at the map for the first time.
Family Tree DNA has given Nick Pasvanis, whose parents trace their ancestors to Greece, Germany, England, and Scotland, a detailed breakdown.
I am 45% Southeastern European, which is about what I expected. I've always felt like I was just a general European mutt, and that's pretty much what the map shows.
So I was wondering when I got it, like if it would say if I was black, and I am 94% West African, so yeah, I'm pretty black.
But Cherry Richardson's African bubble provides little detail. Hannah Wiesman and Viola Wong, who were both born in China, have even bigger bubbles.
I mean, I have just these giant bubbles, and they're like, you're super Asian. Like, I kind of already knew that, so.
Basically, people who have huge bubbles are considered the minorities.
And it's unfortunate because it perpetuates a kind of Eurocentrism that has tainted our scholarship, that is a foundation for false notions of white supremacy, and it highlights the disparities that are currently prevalent throughout science, and particularly in genetics.
There's also 23% Southeast with Italy and Greece highlighted, which was never on our radar.
But there's another problem with the way DTCs calculate ancestry.
64% European.
The DNA of people who lived in a place long ago, your ancestors, may be different from the DNA of the people in the reference groups who live there today. That's because for centuries, people and their DNA have been moving around the globe.
You really have to get over the hurdle of static thinking about human populations, that there are Irish genes and Italian genes and Nigerian genes and Zimbabwean genes, and that's just not the way that human evolution works. Because static feeds into the racist paradigm, feeds into the me versus you, us versus them.
And yet, it is true that certain SNP patterns are more prevalent in some places than others.
There's several clues that can link you back to areas and specific regions where your ancestors evolved. The companies are doing the best they can with the data that they have.
And that's why all the DNA testing companies are trying to add more discrete populations to their database so that when they don't assign your population perfectly, they're as close as they possibly can be.
Bessie and Anita are finding that whatever their flaws, DNA ancestry tests, by making people think about their roots, can help them to better appreciate human diversity.
The north of Africa, Middle East, the Western Europe, but
It makes people think of their stories in relation to other people in the whole story of human migration. Most people have felt this to be a positive experience.
Taekwon Golden's results from Family Tree DNA are very close to those he received from Ancestry.
Can't ignore it now. The whole Ireland and UK part of the DNA.
Let me ask, you think you're as authentically Black as she is?
I don't think it makes a difference.
They sat there and had a conversation about race that was fun and exciting and joining. And if that can happen more and more, what are the possibilities?
But as difficult as determining ancestry may be, the toughest challenge the DTCs are taking on may be assessing our genetic disease risks. Because when it comes to the accuracy of those tests, the stakes couldn't be higher. We all face the risk of developing life-threatening diseases. But some of us face a greater risk because of variations in our genes. Deviations from the precise sequence of A's, C's, G's, and T's that form the genetic code for making proteins, the critical molecules that keep our bodies working.
It is hard to believe that a single letter change could affect a human being so profoundly among this huge string of 3 billion letters. But then you get those critical places where if you've made that specific change, the protein simply doesn't work anymore.
Several of the DTCs now offer testing for genetic health risks. But how reliable are they? Most of those tests look only at selected SNPs and ignore the rest of the genome, where other risks may be lurking, risks that they will inevitably miss. One example, 23andMe's controversial test for breast cancer risk. It looks at 2 genes called BRCA, or BRCA genes. They code for proteins that control cell growth. But certain base pair variations derail the BRCA genes and make some cancers, such as pancreatic, prostate, and especially ovarian and breast cancer, more likely. Scientists have documented close to 4,000 such variations. 23andMe sells a SNP test that looks for 3 of them. They're among the variations that put women at very high risk for breast cancer. Each can be reliably detected by SNP testing. And each is 10 times more common in women who have Ashkenazi Jewish ancestry. Jessica Al-Ghazi, a 52-year-old entertainment lawyer in Los Angeles, has 3 Ashkenazi grandparents. In 2018, she takes the 23andMe BRCA test. having no idea it will change her life. One day, when she's playing golf, she gets an email.
I get the results as I'm sitting on a golf course in a golf cart, and I look down and I'm like, oh my God, I can't believe this.
23andMe reports that she has a BRCA1 variation that makes it highly likely she will develop ovarian or breast cancer. A second test by a DNA lab that specializes in BRCA testing confirms it. Although she is cancer-free for now, she makes a decision.
My gynecologist said, you know, Jess, you got to do something now. You'll have your ovaries and tubes removed, and you need to have a double mastectomy right away. And so I'm just grateful that I was able to find out in time to do something before I got sick. I'm eternally grateful to the folks at 23andMe for giving me that opportunity. They quite possibly saved my life.
But most women who have BRCA variations don't have any of the three that 23andMe tests for. Women like Pamela Munster. She happens to be an oncologist in San Francisco who specializes in breast cancer.
I have the BRCA1 gene.
She has no Ashkenazi Jewish ancestry. In 2010, Pamela takes 23andMe's BRCA test herself.
Do you have siblings? What I learned is that I didn't have much of a breast cancer risk, and by 23andMe's reckon, my breast cancer risk was actually quite low.
But in 2012, Pamela is diagnosed with breast cancer.
And the way my cancer looked under the microscope, I had this sense that this breast cancer was associated with a BRCA mutation.
To confirm her hunch, Pamela has her DNA tested by what's known as a clinical lab, the kind doctors use. They don't just look at scattered SNPs. They look at every single base pair in genes, a process known as sequencing.
They go through the entire BRCA gene, and remember these are like 80,000 base pairs, and they can tell you is the letter there, is the letter not there.
Pamela turns out to be right. She does have a BRCA2 mutation, but it's not any of the three variants 23andMe tests for. It's one of the thousands of others.
If I just want to know who I'm related to, 23andMe, Ancestry are very good tests. If you want to know, do you carry a BRCA gene and are you at risk for breast cancer, I think 23andMe is not an ideal test.
But 23andMe says that its BRCA test has alerted some 3,000 people to their cancer risk. And that choosing these three variants makes sense because they confer such high risks.
What these variations mean for someone's risks is very, very well understood. The studies that have shown nearly half of people carrying one of these variants don't realize it.
So it's great for those people who were not even thinking they were carrying that mutation to pick it up with direct-to-consumer testing. It's not a good thing if those people think they have been exhaustively tested, because they have not.
And there are also concerns about how test takers' data is used. In 2018, 23andMe agrees to share anonymized information about millions of its customers with GlaxoSmithKline to use in the development of new drugs. 23andMe says some 80% of its customers have given consent for their data to be used in research. Most have also filled in health questionnaires, enabling valuable links to be made between their genes and their health histories.
The potential of what you can do with that information is just astounding.
But while the possible rewards of the deal seem clear, to some, it raises ethical questions.
You're actually paying your money to give your data to a company, and then it will be capitalized on potentially without benefit to you. When you're dealing with such a new technology, I think the full implications can't possibly be understood by consumers because things are just too new.
So how safe is the data of 23andMe's 12 million customers?
We do not sell data. We do not share your data with any insurance company or any employer, hard stop, without your consent.
Federal law prohibits most employers from using genetic data to make workplace decisions, and prohibits health insurers from using it to change or deny coverage. But disability and life insurance companies are free to use it. While 23andMe and Family Tree DNA talked with Nova about these issues, AncestryDNA declined to participate in this film. The risks inherent in new technologies often become obvious only in hindsight. Chelsea Rustad could never have predicted that her DNA test might lead the police to a dangerous murder suspect. They found him using a new investigative technique that springs directly from the rise of consumer testing. It's called genetic genealogy. And before it was used to solve crimes, it was used by people looking for their birth parents. One of its pioneers is a retired patent lawyer named Barbara Ray-Venter.
I really backed into this whole thing because I was doing unknown parentage type work with adoptees. For adoptees, DNA has been huge because for them to try and figure out who their birth relatives were just using paper, very, very difficult.
Barbara starts by connecting the adoptee to the people in their DNA match list. Then, by digging through records, she finds more relatives. The goal? Find an ancestor who links everyone together and points directly to the birth parent. In 2017, Barbara is asked by investigators in California to try to solve a different kind of mystery, one of the nation's most notorious cold cases. The so-called Golden State Killer was suspected of committing at least 13 murders and more than 50 rapes during the 1970s and 80s. Police have long had his DNA, but have no idea who he is. Barbara agrees to help. From the crime scene DNA, a SNP profile is made and then uploaded to GEDmatch. Using the relatives who pop up, Barbara creates a family tree and eventually zeroes in on a man named Joseph D'Angelo. A one-time policeman, D'Angelo had never been under suspicion. Police collect his DNA and run an STR test. The result? A perfect match with the DNA of the Golden State Killer.
Murder in the first degree. That charge, sir, how do you plead?
In June 2020, Joseph D'Angelo pleads guilty to 13 counts of murder.
Guilty.
He is sentenced to life in prison. At the time of D'Angelo's arrest, Detective Jim Scharf is amazed to learn what's been accomplished using genetic genealogy. He quickly thinks about Tanya and Jay. He reaches out to a computer scientist he's been working with in Virginia, Steve Armentrout.
So do I need to hardwire the number in here, or am I doing a calculation?
Steve's company, Parabon Nanolabs, has developed methods and software for sifting through hundreds of thousands of SNPs.
We first have to get DNA from the crime scene into a format that can be used for uploading. Jim gave us the okay on a Thursday. On Friday, we were uploading to GEDmatch.
Steve has teamed up with a genetic genealogist in California, CeCe Moore.
On Saturday morning, I rolled out of bed before I even put my contact in and flipped open my laptop to see if we had that match list, and we did.
GEDmatch shows two people who each share around 3% with the unknown suspect.
So to have two people that shared about 3% of their DNA, or enough to be a second cousin with the suspect, did feel like getting struck by lightning. Second cousins will share a set of great-grandparents, and that's not that far back in the tree. In genealogy, I can almost always get back to someone's great-grandparents.
One of Cece's 2 top matches is Chelsea Rustad. The other is a cousin who's never been publicly identified. They both share DNA with the suspect, but don't share any with each other.
That meant that they represented different branches of the suspect's family tree. I really lucked out. I found an obituary from a woman who was carrying the surname that I had just seen in the other match's family tree. So that told me we have a woman from this tree and a man from this tree who have married and hopefully had children.
Cece knows that if they did, those children would carry a mix of DNA very similar to that of the suspect. The couple had 4 children.
We got really lucky that there was only one male in this family because the genetic genealogy was pointing at one person and only one person, and that was William Earl Talbot II.
At the time of the murders, Talbot lived a few miles from the bridge where Jay Cook's body was found. Now, he is 55, a truck driver. The police follow him. They want his DNA to see if it matches the DNA from the crime scene. One day, they get lucky. A drinking cup falls out of his truck. Jim Scharf brings the cup to the Washington State Patrol Crime Lab for STR testing. Lab supervisor Lisa Collins asks him to wait. Soon, she returns.
Lisa turned and handed me the report and said, "Jim, it's him. There's a match." And I couldn't believe it. My eyes teared up. I yelled out a scream, "This is wonderful. We finally got this guy."
On May 17, 2018, William Earl Talbot II is arrested on a charge of first-degree murder for a 31-year-old crime. He's a man who was identified not because he took a DNA test, but because a relative did, someone he'd never even met. In June 2019, the jury delivers its verdict.
We, the jury, find the defendant, William Earl Talbot II, guilty of the crime of first-degree murder as charged in count 1.
Talbot is the first suspect identified by genetic genealogy ever to be convicted by a jury. He is soon sentenced to 2 consecutive life terms in prison.
It has been reiterated to me so many times by the investigators that they wouldn't have come this far without my DNA. It would have been dead in the water.
Since Talbot's conviction, the Parabon team has used genetic genealogy to identify more than 100 criminal suspects. But just being named by a genealogist isn't enough to get a person arrested.
We have to get confirmation DNA using STR testing before we have probable cause to make an arrest.
Even so, to critics, the use of genetic genealogy by law enforcement raises privacy questions.
Do we want to catch people who have committed heinous crimes? Absolutely yes. But what DNA profiles are being trolled through? What failed attempts to find suspects are we not hearing about, and the data violations and privacy violations that happen along the way?
The genetic genealogy team at Parabon says the fears are exaggerated.
People have control over whether their DNA is used in these investigations. Simply taking a DNA test at 23andMe, at Ancestry, your DNA is in their private database.
But there's little regulation, and policies vary. In 2019, Family Tree DNA apologized for letting the FBI search its database for people who share DNA with crime scene samples without customers' permission. Family Tree DNA and GEDmatch both now say they only do so with explicit permission. And another worry? Consumer DNA companies, like any that collect data, are vulnerable to hackers. Yet the risks are clearly not deterring everyone.
No one is forcing anyone to take a DNA test. If your paranoia and fear of Big Brother is greater than your interest in reading the medical and history book written into your cells, then I think that you should not test.
There's beauty in, understanding where you're from and then searching for that.
The consumer DNA phenomenon is changing many people's lives by revealing the secrets that lie hidden deep inside ourselves. But are its benefits worth its cost and risks?
Do I want to know that I'm at risk for Alzheimer's when there's absolutely nothing I can do about it? Maybe not.
With these DNA tests as popular as they are, the chances are that everyone who has had a secret of this nature kept from them is going to find out. Our hearts and our minds don't know fully how to grapple with what we're being asked to grapple with.
I think the surge in DNA testing over the last 20 years has opened people's minds to the possibility that they share more with other people than what they thought they did.
That 1% that makes us different is really just the beautiful diversity in the natural world. And it's not that one genotype or genome is better than another, it's just they're beautifully different.
The more we are tested, the more we see how connected we are to each other. And perhaps if we see that we're connected to each other, we'll treat each other a little bit better.
To order this program on DVD, visit Shop PBS or call 1-800-PLAY-PBS. Episodes of Nova are available with Passport. Nova is also available on Amazon Prime Video.